We are living in a data-centric world. You might not realize, but data influences nearly every important decision you'll make on a daily basis. Consider your daily commute. You leave at a particular time or take a particular route based on your understanding of traffic data. You choose a particular restaurant after work or select a hairstylist based on Yelp reviews. You vote and influence the entire direction of your local, national, and global community based on your understanding of political trends or voting records. There is so much data that an entire field, data analytics, exists to make sense of it all. But what about people like you and me? How can we take advantage of all of this information to make everyday decisions or come to better informed conclusions? We're talking today with Georgia Tech's Assistant Professor Alex Endert, an expert in visual analytics and data visualization, who is working to make data more accessible to the general public. I'm Ayanna Howard, Chair of Georgia Tech's School of Interactive Computing, and this is the Interaction Hour. Professor Alex Endert directs the Visual Analytics Lab at Georgia Tech, where he and his students explore novel interaction techniques for visual analytics. He earned his PhD from Virginia Tech in 2012 and earned a career award from the National Science Foundation in 2018 on visual analytics by demonstration. Alex, thanks for joining us.
Yeah, thanks so much for having me. This is really exciting.
So before we get into this discussion, I want to give you a quick plug. You and many others in the School of Interactive Computing's Visualization Lab will be at IEEE Viz October 20th to 25th in Vancouver. Tell us a little about that.
Sure. So IEEE Viz is the premier Viz research conference that we have in the field. It's actually made up of 3 individual conferences that come together to make this full 1-week schedule. So V actually stands for Visual Analytics, Science and Technology, I stands for InfoViz, and S stands for SciViz. And a while back, actually, they all decided to come together and sort of make this one more cohesive conference that we have. And our lab typically has quite a few papers there every year. And we present the work there. Our students primarily do. And it's been a lot of fun.
Sounds awesome.
Yeah.
So we're going to go a little bit into this visual analytics that you described in terms of IEEE Viz. So I really want to nail down when we say visualization or visual analytics, I mean, what are we referring to? Who does it impact? I mean, what's the goal of creating these interactive tools for people to explore data?
Mm-hmm. Yeah, so the high-level goal, I would say, is to help people make sense of data. And we do that in visualization or visual analytics through visual representations of information. That can be static and used for presentation purposes. So for example, you have found something or you want to present information in front of an audience, and you might do that using visual representations in form of a PowerPoint slide or in print or so on. And then there's this other use, which is typically considered more this analytics side of it, where you have some data and your goal is to make sense of it, to analyze it, to answer some question. And you do that with interactively exploring the information and changing the visual representation and so on. That's actually used by quite a few folks, whether it's just sort of the general public consuming information through print, through media, or whether that's analysts in a specific role for a specific domain needing to analyze their information to ask or answer some kind of question.
Okay, so making sense of data, that makes sense. So why now? I mean, we've gotten away with years and years and years with having experts tell us what data means. I mean that's been their role. They interpret the data. We trust their interpretations and make decisions on this valid information. So what could possibly go wrong?
Well, like you mentioned when you opened it, right? I think in today's sort of data-driven era that we're in, we're seeing information not only be reserved for this elite tier of experts in order to use and then drive decisions down to the rest of us who don't have access to this information. I think what you're seeing is information that's available to everybody for many different reasons. And therefore, right, there's this need now that we have as people, not just these quote experts, to actually analyze this information or understand it to some degree. And I think what we're seeing in Viz is the ability to, not replace experts. I think there will always be experts that are good at what they do in the domain that they're in, but potentially make those experts better at what they do using visualization as one of the tools in sort of their data science toolbox. But also sort of people who just have sort of your non-traditional data analysis tasks to allow them to actually make sense of information that, maybe if we look back many years ago, it just wasn't a data-driven problem, but now is.
So I like this concept of bringing the non-expert, and really it's about holding the elite experts accountable by giving us the tools. So if you think about these non-experts and bringing them into the mix and making data more usable, how, like the specific things, what has your lab done to address these challenges?
Yeah, so I think broadly speaking, we've done things in a number of domains that help people make sense of information. For example, right, we might visualize different voting patterns, or we might visualize sports data to make it sort of more accessible to people and get them to understand it in a different way, or maybe confirm what they already knew about liking certain sports teams and not liking other ones and thinking they're better and so on. But we've also done things to actually help data analysis problems for experts actually that are sort of professionally trained analysts, and we help them actually analyze their data using something that we sometimes call mixed initiative tools, where there is a certain amount of the effort that's spent on the system's behalf balanced with the user's behalf, right? So it's not just sort of users driving the whole process, but also systems and users sort of working together in order to perform certain tasks of data analysis.
So you mentioned these mixed initiative tools for data analysis, but you mentioned something about sports and data for sports. And I kind of want to, I occasionally look at sports. I like a good game of basketball. So give us an example of, what kind of data you're looking at. Specifically, we're going to use this sports example.
Yeah, so sports is fun because most sports now are pretty data-driven, and people are fans of sports, and they like to look at data in order to sort of see some things, right? One of the things that our lab has been looking at quite a bit is how data visualization and interactive visualization actually might sort of intersect with this idea of being biased about certain criteria or certain aspects of the data. And sports is, again, a great domain for that because, fans are exactly that. They're a fanatic about their team, even in the face of some data that might actually refute that or contradict that in some way. And so we've run actually a series of studies about this to try to understand how we can build visual analytic tools that try to alert people that they are being biased in some way. And we used a sport example as one of the ones that we tried that on. And it was a pretty simple scenario, right? It was giving people a task to say, can you label some basketball players based on the position that they play? And we're going to give you some attributes about them, right? The number of rebounds they have or how tall they are, so on and so forth. In two different conditions, we tested two different ways. One of them, we gave the example of what certain positions are in terms of their height and their weight. Right? So nothing about sort of how many three-pointers they take or how many rebounds they get. That was the other condition, right? We said in the other condition, nothing about their height and weight, all about just, centers tend to get more rebounds and blocks than point guards and so on. And what we found as a result of the study was that the criteria by which you anchor people about the description of what players, quote unquote, should be definitely drove their decision-making process and their interactive visualization process along those lines of those descriptions.
Okay, so that was basketball. This is fun. Okay, let's choose another one.
Okay.
Let's do baseball. You have anything on baseball?
Yeah, so baseball, there's an interesting example that we ran across recently, which touches on a line of research that we do that has to do with making machine learning easier for non-data scientists. And one of the examples that we have there that we looked at, which is sort of touches on why even have humans in the loop when it comes to machine learning anyway, has to do with a pretty simple task, which is build a machine learning model to help predict which baseball players are going to get into the Hall of Fame. Right? And so we have a whole bunch of data about a whole bunch of players in the past that have gotten into the Hall of Fame and their stats they've had over, how many home runs they've hit or how many hits they've gotten, so on and so forth. And we have the pleasure of working with some folks that are, I guess, experts in that domain of being able to say, who may or may not get into the Hall of Fame. And it was interesting because when we started that line of work, one of the things that we found was we immediately sat down, we had this nice interface and everything sort of prototyped out and said, nice, now all you can do is sort of say, what things are important, right? What might be some of these rules or heuristics that actually help people determine whether or not someone's going to get into the Hall of Fame. And somebody immediately said, well, you're missing something. And this was always interesting, right? Because you go, well, what are we missing? And one of the things that turns out we were missing was some sort of domain expertise on behalf of this user that said, well, you're missing the idea that, there was a steroid era in baseball, and that's nowhere in this data set. And so, this person didn't feel that he was able to confidently build a machine learning model without this information because it was so critical to this domain-specific task of saying who's going to get in the Hall of Fame or not.
Okay, so these are examples, sports examples about how domain experts and how do you give them the tools to really improve their own representational understanding of the data. So let's talk a little bit about a harder subject. So we are, again, inundated with all this data. So what about data that says, influences public policy or laws that will impact society? There's so much information right now, for example, with respect to the political spectrum and major policy decisions. Is there a way that we can also take advantage of tools like you mentioned to inform us of how we vote, how we select representation, and those kind of things?
Yeah. In sort of the political side of things, I think there's a lot of data, and in some cases even, one might argue too much data in order to make sense of it, to come to some decision that's grounded in data about, who you might vote for, or just to get an understanding of reasoning that went into a vote that went one way or another. And one of the things, again, that we're looking at there is actually to understand how social biases might impact the way that people analyze data and make decisions, especially grounded in sort of political examples. One of the ones that I can point to is from my PhD student, Emily Wall, who's actually looking at how the spectrum of where you fall between being voting more Democratic, more Republican, might actually impact the choice of, say, a fictitious committee about reviewing a bill in Georgia or some other state and choosing sort of a committee made up of politicians. And it's really interesting to look at that because it might help give rise to this idea that visualizations or visual analytic tools could understand some of these biased processes that people do and make these implicit biases more explicit during the data analysis process, and ideally before a decision is made. Right? A lot of cognitive science has studied bias sort of post hoc and said, oh, well, look at all these factors that led to a biased outcome. But if that outcome has already happened, it's almost too late. And we're really trying to drive that into the sort of real-time data analysis or visual analytic process as opposed to afterwards.
And so this is basically for everyone else who is maybe not necessarily a domain expert about, say, some of these laws that are coming up.
Right. And it generalizes sort of beyond that a little bit as well, right? I mean, there's these very specific examples of, say, you have to choose a committee to review some bill, but it also generalizes to just saying sort of most decision-making processes, which, are usually aided by some AI agent or machine learning model or some sort of computation, but ultimately still fall on sort of a single person or a committee of people to make a decision of some sort. And especially, in that realm, I think the idea of having systems try to alert you of potentially biased processes is something that most people would argue would be a very good thing to have, right? I mean, you certainly would not want people to say, well, this is a decision, we made it, but we may have been biased, right? I think that's something where most people could agree. You want to try to mitigate that if possible.
So you talk about biased processes or decision-making process. So this brings us an interesting question, though. This is assuming that the information that's being put into these visualization tools is not biased either. It's pure because data is pure. We see this in journalism and popular culture all the time. Someone takes data, they may not have all of the data, they might be misinformed about the data, they misrepresent the data. What happens when the data itself or the tool itself is flawed?
Yeah, you touch on a good point, right? The bread and butter of InfoViz, so to say, is to effectively and accurately represent the information given, right? And so, right, if you say you have a lot of information and you choose to filter only a subset that makes a certain point or a certain perspective, and you give that to an InfoViz designer, right, they might say, well, if this is all the data I'm given, then it's my goal to make it as effective as possible to show the data set that you just gave, even if it's a chosen subset of the data, right? But more broadly, I do think it raises sort of an issue about sort of knowing the way that InfoViz impacts the perception and the cognitive processes of people. And you could use that, for the better to say, wow, we're really trying to optimize the bandwidth of this channel between data and someone's knowledge by using visualization. But right, the other side of that is to say, well, if you know all the guidelines and you know all the science that goes behind it, you could actually, use that to your advantage to show information in a way that proves your point and maybe diminishes sort of the effectiveness or the accuracy criteria of the visualization given the data that you have.
So this is how you can then inject your own biases using the tools.
Yes. And biases, right? A lot of times I think the ones I've talked about here, like social biases or things like that, are implicit biases, right? They're biases that maybe people are not aware of, yet just, our innate behavior can't help but the fact that we rely on these biases in order to behave in the world. Some of these that we're talking about here, I think, it may actually be more explicit, right? It may be, I know I'm trying to prove this side of the story as opposed to the other one, and therefore let me try to create a visualization that, intentionally does things where most Viz people would look at that and go, ooh, that could be very misleading there.
So, I totally believe in AI and artificial intelligence, that it can make us better at what we're doing. And so are there ways we can arm these tools or even maybe ourselves against these like confirmation biases, implicit biases? Do you have anything in your lab I can borrow and give to some other people that I might know?
There are things you can do, right? I think one of the things actually has to do with you see it in media more often now when there is a graphic of some sort or some sort of visual representation of information, you see sort of the source of information listed there as well. And I think that's a great standard by which, maybe media or websites in general should sort of abide by saying, if one does see a visualization and it is effective at capturing and engaging your audience by going, oh, wow, I never thought that there was a peak of something at this time, is to actually be able to go, okay, well, let me drill down into that data a little bit more because I'm very curious now and I want to see more information about what's happening at this particular point. And I think that might help sort of keep people a bit more alert or skeptical about what they're seeing in certain infographics or certain visualizations. But also I think it might lead them to actually explore the data further and gain a lot more knowledge about a particular topic or a particular data set than they would out of just seeing sort of a subset of a bar chart or a pie chart filtered a certain way with a certain narrative that goes along with it.
And so that's the goal. One, providing us the ability to better understand, better interact with data, but also to ensure that the experts that are out there aren't necessarily hiding their visualizations to influence our decisions.
Yeah, I mean, I think there's a growing list of folks inside the community and the Viz community that would say, visualization is really a medium by which people and data can interact, right? And that is, literal interaction, meaning I want to filter something or click on something, but also interact in terms of sort of the presentation or the way that we understand data, regardless of field, regardless of domain, and saying, if it's visual, that is sort of intended for a human to understand that information.
So this is great. So I learned a little bit about sports and using visualization tools to predict Hall of Famers. I learned about biases and what we can do to basically protect ourselves from the bias that might be presented in our own decision-making process. And most of all, I learned about this world of visual analytics. This is great.
Yeah. Well, thanks so much for having me. This has been a lot of fun.
We appreciate Alex for joining the Interaction Hour and encourage you to follow all of our coverage of IEEE Viz online now at ic.gatech.edu. Follow us on Twitter and Facebook at IC@GT for updates about this conference and much more. Thanks for listening.